Yo, good evening and welcome to the Man Cave. Tonight I'm going to start building my Skywalker X6. So I'm going to do this bit of a build blog and then you can see what the crack is building up an X6. This evening, sticking the sides together. I've kind of already cheated, already started, and I've put some U-Pour glue just around the outside edge of that side and the outside edge of that side. So U-Pour glue, it's absolutely fantastic for these foam models. It's foam safe, it's contact adhesive, so you put it on both surfaces. So put some on that surface first, put some on that surface. I just kind of rub it in with a bit of card, and then you let it set for probably about 15 to 20 minutes. After that, you basically, all I'm going to do is put that side onto that side and jobs are good in. So here we are on the workbench, ready to rock and roll. This is a U-Pour. It comes with a kit, or you can just buy it U-Pour. It's really good. It's just a simple contact adhesive. The idea is that you just put it on. It's very thin. It's nearly water-like viscosity. Then you just spread it in, and when you spread it in, it takes maybe about 15-20 minutes to dry. So it's contact adhesive. The idea is you put it on this side and you pop it on the other side as well. So I put it on both sides. What we're going to do next is literally flip it over and just stick it on. It's as easy as that. So let's stick it together and see what happens. This could go horribly wrong. So the idea is that I'm going to line it up. I normally start right at the back. So I'm going to pop the motor on first. I'm going to get the tail edge lined up, and I'm just doing that by touch. Get my fingers on the edge of that and just lining it up. And as I go, I'm kind of lining it up as I go along, just with my fingers, to make sure that everything joins together nice and smooth. So concentrate, Simon, concentrate. So I've got the bottom in pretty much. I'm just going to gently roll her over. I'll check that I've got the top lined up. Everything must line up, must be straight. There we go, that's looking kind of good. So now I can apply a bit of pressure. And the idea of applying the pressure is to make sure both surfaces are bonding together. Let's have a look at that. And hallelujah, hallelujah. On the bottom, we've got all this room down at the bottom here. It's exposed EPP foam, and as soon as that touches the deck, it's going to get ripped to shreds. So I'm going to put some tape on it. The idea of putting the tape on is obviously enough to protect the bottom. So I'm going to put a run of fibre tape down it. So if I can find the end of it. Got the end. I'm going to simply line this up in the centre. Gently put it on. Nice and neat. I think there's a little space there for like a jockey wheel or something like that, but you don't know in that. I crashed it long before then. So nice sharpened the blade. Straight through the fibre tape there. I'm just going to rub this down and make sure it's on. There we go. Looking good. So that fibre tape will just protect the bottom of my newly purchased X6. I'm going to fold it into this crack here. Nice. And there we go. One of the things I want to do is run through all the kit I'm going to be putting inside the Skywalker X6. I want to make this a long-range FPV aircraft. And one way I'm going to do that is with good quality kit. I'm going to want a good solid video link, I'm going to want a good solid radio link, and I'm going to want a good quality FPV camera. Couple all that together, you've got a fantastic FPV system, but for peace of mind we're going to use an autopilot as well, which has got return to home functions on it, stability functions on it, loiter functions on it, of which I'll all explain later. Want a good quality motor on there, good quality ESC, and couple that with a battery and all the other bits and bobs, and what an FPV system we have. I'll run through the parts with you now and we'll explain each one in a little bit more detail. So, what do we have here then? Well, an absolute load of FPV gear on this table, and we'll start with the basics. I'm going to want to see this thing, especially if it's above me. If it's a bit dark, I'm going to want to see it. So, I'm going to put some LED strips on, a small LED strip here. It works off 12 volts, so I'm just going to have to put a 12 volt feed to this. I've got the Strobotron as well. I'm going to put this on the base of the aircraft. This thing is super, super, super bright, and hopefully that flashing will just help me see if it's above us. No good for long distance, but we'll just use it. It's a bit of a gimmick. We'll see. So we've got some lights on the X6. Next thing, if it decides to stuff itself or I land it in some long grass, I'm going to want to find it. Well, this thing here is a lost model locator, a little lost model alarm. It's simply just a little buzzer. I'm going to wire that up to channel 7 and set it when my failsafe comes on that this comes on as well and buzzes nice and loud, so I can find it if it's in long grass or stuff it on the side of a hill or somewhere where essentially can't find it, maybe up in some trees. Really, really loud buzzer, really useful for finding lost models. Let's have a look at the autopilot. The autopilot I'm going to be using in this model is the Vector. I've had this Vector for a long time, pretty much got it as soon as it came out, and it is an absolutely solid and reliable autopilot. We've got the actual autopilot unit itself, we've got a GPS module, and we've got a power module. Absolutely fantastic, really good bit of kit. The main thing is it's going to give you return to home function if you lose your signal. We've got stability control, so you can just let off the controls and it'll stay flat and level and on heading. We've got loiter function, which is really important, I find, so I can launch the aircraft, line of sight, get it up, put it into a loiter, put my goggles on, and off I go for an FPV flight. So the autopilot's really useful. I'm going to be using the RunCam. The RunCam Eagle, it's the 140-degree RunCam at a 4:3 aspect ratio. I find this works really well with my Fat Shark goggles. I'm using the Dominator V2s, so they're a bit of an older set, and 4:3 works really nice with those. Get a really nice, good quality video picture. The camera, I want to try and get the best picture I can from an analog signal, and this camera certainly does that. So the camera's then coupled up to a 1.3 gigahertz 1000 milliwatt video transmitter. Absolutely huge amount of power on this video transmitter. It kicks out the video signal for a very long way, and to be honest, the video signal is probably going to outrun the radio control signal with this system, so I'm always going to get decent video. Considering I'm using a very directional antenna with this as well, it certainly helps out. Antenna wise, I'm using the IB Crazy antennas. These are absolutely awesome. If you want good quality video, get good quality antennas. You can see that they just screw on with a simple SMA connection. I put a right angle connection in there, slight drop of signal there, but or power or whatever you want to call it, but it's not going to make any difference really, considering. So that's the video transmitter sorted, nice and easy. Next thing, radio control. Couple of options, easy UHF or the TBS Crossfire. I've gone for easy UHF. The only reason I've gone for that, I've got loads of these receivers, and the JR module fits really snug into the back of my Taranis. So we've got easy UHF there, got the Taranis coupled up to this with a JR module in the back. I've got an SHR 771 antenna on the Taranis on the JR module. And then I'm just going to use these, the stock antennas basically. They are good enough. I've had over 25 kilometres with these bad boys, so I don't think I'll be going much further than that. That said, I probably will if I decide to cross the English Channel. But we're going to go for some nice long range. And essentially, the main thing that I'm looking for is good solid link. This gives me a good solid link. If all goes wrong, if I lose signal, I can flick up the power on my easy UHF transmitter module. If that all goes wrong, I've got the autopilot to bring me home as well. Nice, easy, good, solid radio control link, certainly what we want. The servos I'm using are these Corona metal geared ones. It is a DS339 HV Corona servo. Metal geared, very strong gears. Certainly a lot better than using plastic gears that can strip. However, it does have an Achilles heel, and this is what caused my last X6 to crash, is the bolt that actually holds the servo horn on. I did not bother putting thread lock on. Big mistake, really, because what happened was, as you can see, the actual bolt vibrated out, servo horn came off, absolutely no control whatsoever, splat into a hillside. So in a nutshell, make sure we're going to put some thread lock on this. Certainly don't want you doing the same mistake. So thread lock your nuts, boys, thread lock your nuts. Also, for connecting the wings, we're going with these bad boys here. When we connect the wings together, I don't want to be connecting a load of servo cables. These come standard in the X6 kit, and these connectors are beautiful because they just slot together like that. All the wires on that side, lots of wires on that side that we can connect up, and then it just saves plugging loads of servo connectors in. These haven't failed on the last one, and they fit really beautifully together like that. Really good connectors for the wings. Last but not least, speed controllers. I'm using the Turnigy Plush 60 amp. It says it's bulletproof speed controller. I've not shot it, so not sure if that's true or not, but this speed controller has done me proud. It's good, 60 amps. The motor itself is the OMA 3825. It's 750 kV. This motor has got a huge amount of power, and it is really efficient. Full chat with 12x8 on it, we're pulling about 40 amps, so 60 amp speed controller as well within its boundaries there. This motor with a 12x8 on, absolute blinder of motor, loads of power. It'll just put the X6 vertical, no problems at all until you want it to stop. And it's certainly something that I'm looking for, is loads of power. It's not too heavy, it doesn't make the tail heavy on the aircraft, which is a massive problem on wings. Yet if I throttle back, I can cruise at sort of 7 or 8 amp, and with a 10 amp battery in, that essentially is going to equate to easy 1 hour flight times, which is certainly possible with this. You're cruising about 45 mile an hour at that as well. One thing we're going to need inside the front of the X6 is something to hold the battery in place. In this instance, I'm just using a bit of 4mm Corex. We've got a Velcro strap around there, and I'm just simply going to hot glue gun that on the bottom, and I'm going to stick it in place. Easy as that. So, time for the hot glue gun. I'll put some actually on the bottom of the Velcro strap as well. Loads of glue, yes. Make sure the Velcro strap's out of the way. I'm going to just simply pop that in place. I've cut it pretty much the right size. The other bonus of this is it's obviously going to strengthen up the bottom. It's across the join, the middle of the airframe there, and with all this in place, it's adding a little bit of reinforcement to the front of the airframe, just helping the bottom of that airframe stay together through those rough landings, because invariably this is going to get a knock, because this is going to be used in some fairly hostile places, I should think. So there we go, we'll let that set, and then that there is a really nice way of holding that big 10 amp battery in place. Hot glue, our best friend. This is the bottom of the wing, and you can see it's really handily been cut out for video transmitters. We can obviously get the radio control receivers in there as well, but for this instance we're going to look at installing 1.3 1.2 gigahertz 1000 milliwatt transmitter right in there. So problem number one, it don't quite fit. So all we're going to do is I'm going to shave a little bit of this foam off here, and we should be able to make that fit. So line up my ruler, steel ruler, fingers out of the way. Don't want to chop my fingers off, that would be a little bit upsetting. And I'm just going to simply go down with my knife and just start taking some of that foam off. With this EPP foam, it is certainly a great idea to make sure you have a very sharp knife. Reason being is if you don't have a really sharp knife, the foam can snag, and when you snag the foam, it just ends up a really messy, nasty cut, and it's certainly something that you don't want. Take pride in your build. I don't think there's much point in rushing a build unless you need to be like at a race the next day or something like that. As you can see, you'll then get a really nice, neat cut. The foam you can just pretty much pull off, just to finish it off and make sure we've got a nice, clean cut. The FPV transmitter will now fit in there quite nicely. There's some room around the edges, so what I'm probably going to do is infill that at the sides and the back here with a bit of spare foam, just to make sure it's a really nice, tight fit, preferably an interference fit. If that slots in, that stays in there, and without wiggling about. You don't want vibration or anything like that. I'll be a happy man. If you've got some vibration, it could vibrate this really small cable out the side. If that goes, your video goes, you're screwed. You're not being able to see at all. and it's a return to home thing, then with hope that obviously it will return to home. So I'm going to put some foam in the sides here and just pack that up a little bit. Bit of spare foam here. Just going to cut this down to size to fit into that bay. So first of all, nice straight cut down there, a loop, and then I've marked it out at the bottom down here as well, so just try and get a parallel line. You see where that mark is? There it is. That parallel with the top, it's pretty much there. We'll mark down. I'm just going to cut that. So that should, he says, fit in there nice and tight, which it does. So that's a nice tight fit. The next thing, put my video transmitter where I want it, which is there, and I'm simply, the easiest thing to do here is simply mark around it with a permanent marker, like so, and then we can see exactly where it needs cutting. So that's where it's going to sit, and I'm just going to cut that out now nice and neat. Now remember, you always cut on the inside of the waist. Don't cut on the outside, because then it'd be too big. Cut on the inside of the waist. But basically, don't cut on your lines. Cut on the inside of your lines, and then, because if you cut on your lines, it's dead on the size of the video transmitter, and therefore it might be a little bit too big. I'm just going to cut this to size. Remember, nice sharp knife, definitely the way to go with this EPP, and go through it a few times. Don't be afraid to go over the same line a few times. If you just go over it once, it will snag and tear the foam, and if you're looking for a good quality job, you certainly don't want some foam that's just been ragged to bits. It's not the greatest foam in the world, this EPP, for cutting with a blunt blade, and to be fair, I don't think anything is. So there we go. What I'm going to do, I'm also going to take a very small notch at the bottom of this here, because that is where the wires are going to come out of for the video transmitter. So we want a little bit of space just there for the wires to come out of, because I can then place that in there. Test fit that. Oh, fits like a glove. Yes. So push that down into place. That will now push into place. It's an interference fit, certainly what I wanted, nice and tight. And there she is in place, and that's not going anywhere. The other thing I'm going to do with this is I'm going to put some tape over the top to seal it in place, but ideally that's in place now. That's not going anywhere at all, which is ideal. We don't want that wobbling about, we don't want it vibrating about. If it does vibrate about, big issue is that wire right there is going to come out, lose video, we're screwed. Okay, that was good. Need some wires on it next. So it's time to place this servo in this wing. I've got the Corona DS339 HV metal geared servos. Just remember, the main problem with metal gear servos is that the actual bolt holding the servo horn on can vibrate loose. I found this out through my error, and it piled into the hillside, so we're certainly going to put some thread lock on this. Don't do it straight away. Obviously we need to make sure we know where centre is on the servo. There's no point putting your bolt in and then finding that your servo's pointing the wrong way. So we're going to do that later. First things first though, we are going to mount this servo in this wing, and I've lined up the actual servo horn here. There's a bit of space here, so I want a little bit of space here. I don't want to have the servo horn binding at any part. I'm going to get the servo nice and straight in the tray, and then as you can see, well, you might not be able to see because my finger's in the way, but there needs to be a bit of foam removed from here, so I'm just going to mark that out with my permanent marker. Nice fine tip permanent marker, there we go. And now hopefully you should see how much foam I've got to remove. Dead easy to do this. I'm just going to go in with a very sharp knife blade down the foam to the bottom. Same on this one here. Nice and sharp, easy peasy. and then I'm just going to go across the bottom to remove that foam, and then this foam will just simply come out. Easy as that. Next thing we want to look at essentially is where these blocks are going to sit, so where you basically bolt it into a traditional airframe. The idea would be that I'm just going to push these down into the foam, and then you just leave a small little divot here, and all I'm going to do is I'm just going to run my knife blade in like that, same on the other side of the little divot, and then I'm going to take that excess out with a screwdriver. So same on the other side, I'm going to run in, I'm going to get a nice sharp screwdriver, flathead, and I'm just going to run it down and essentially just dig that foam out like so. Get 2 bits of foam out, chuck them. Servo test fit. Does it fit? Does it fit? Yes, it does. Now this servo, it's obviously in a foam wing. You're not going to be able to bolt it down unless you put some sort of 3D printed part, adding extra weight, blah blah blah. So what I'm going to do with this, I'm going to do the sort of cheating option. I'm going to hot glue gun this in place, and then I'm going to tape over the top as well. Sort of pre-flight checks, I can just check that it's not loose, and various other things. But I've hot glued these in before. They don't get too hot. They're not going to get hot enough to melt the glue, and it'll stay in there pretty much until you want to take it out. Taking it out with it being hot glue, you can just yank it out, I suppose. So we'll hot glue gun that in. Once we have centered the servo, once we've checked the autopilot, once we've got everything set up, don't hot glue it in at this point, because you might need to take it out to change or adjust the servo horn. So I've got the wire here, just punch a small hole in through the foam there. The wire's going to come out this side, it's going to run down this track here to these small connectors that I showed you earlier, and I'm going to solder the wires onto the back of this, and it's just a matter of plug and fly, basically. Easy as that. Strippers. I love strippers, especially these type of strippers for doing wire. Absolutely fantastic. If you've got some wire such as this, there's 2 ways of doing it. You either have fingernails and you give it a go, and you can sometimes get the wire stripped off with your fingernails. The other way is your teeth, and then you get a mouthful of wire, or the other option is to use a good quality stripper and simply strip the wire like so. Easy peasy. Definitely worth getting a decent pair of strippers. There's nothing worse than having a naff stripper. The more you pay for your strippers, generally the better they are. Stripping made easy. Yeah.